This is session 5 on AI and human, you will excuse me because my voice is out. So it's AI and human values. And to me, it's the occasion to go back to basics. So we will have various speakers. Eric Salobir will talk first, and we will take a few questions for him right after, because he has to leave right away, unfortunately. Then we will have Ricardo Baeza-Yates. We'll talk about biases. And then Francesco about fairness, and then Kate about political and things like that, and then Laurence about nudging. If I could get the next slide, it's probably this one. Yes. So basically, as an introduction, I would like to remind a few basic things. AI programming, an AI program is produced in a very different ways from the usual computer science way. We've all been trained to produce algorithms from specification, technical specification, algorithm, and we encode the algorithm. AI is different. In AI, what happens is that there is a data scientist, and the data scientist chooses an algorithm and data. And the process for doing that is not at all formalized. That is to say, there is nothing which says that this data scientist has chosen the right algorithm or the right data. The result of that, we run the algorithm on the data, fine, and we get our program, and then we use it as usual. But this little difference makes an enormous impact on what's going to happen afterwards. That is to say, if ever the algorithm has been chosen wrongly, this is not too bad because we have techniques to evaluate and compare algorithms. But if the data itself is, quote unquote, wrong, for whichever reason, then we will face a lot of trouble. And this is basically what we are going to talk about today. One thing which is obvious is that in addition to this problem, little problem, that the data scientist is really in the loop and has no formal way of ensuring that everything is fine, the data basically that we use, which to me are the crucial problem, the data is really the issue we have. The data basically reflect our society. Our society is biased. Our society has lots of problems in it, as we can see everywhere in the world. We see people in the street protesting. There is a reason for that, I guess. So the data we have reflect biases in our society, and typically we have to have ways to analyze these biases and to understand. So let me show you a very typical example. Everybody knows this example is from one paper which has become very famous and has been mentioned a few times, I think, already here. If you make a system for face recognition, or more precisely for gender recognition, you end up with a system which is working really beautifully on the left top part for, let's say, white male. The white male is perfect, 1% mistake for identifying the gender. But if you are dark-colored women, bottom right, the error rate is 35%. It means that identifying your gender means that you get access to a service. Yes, no. Dark-skinned women do not get that service. So this is one of the things that we have to work about. This is what has been called now bias in, bias out, BIBO. And basically, this has impact on gender, minority, whatever, and we will talk about these issues. Now, the fundamental rights and AI, we've talked a little bit here during various talks about the document that the EU has produced, and I'm a member of his AI high-level expert group for that. The ethics document has taken as a ground the rights of the people, the fundamental rights. So we start from the fundamental rights, and this is what is the foundation of our society. I remember the first meeting we had at the Commission, we said, what is it we want to protect? What makes Europe different? Why is Europe different from the US and China? Can you summarize that in a short list? And this is basically, respect for human dignity, freedom, et cetera, et cetera. These are things which are at the basis of our society. And basically, all these topics is what we are going to cover in this session, right? So our first speaker is Eric Salobir from the Office of Priest for ICT. Please, Eric, the ground is yours.
Thank you very much. Good morning, everybody. Thank you for coming so early. I hope that caffeine has already an effect on you. Unfortunately, it doesn't have on me yet, so please have mercy. However, that's my pleasure to be here today, and perhaps to start my presentation with good news. And this good news is that in our globalized and very overcrowded world, you are unique. I mean, you, Bertrand, you and me, we are unique because the products we buy, the prices of those products, the information and news we read or we listen, all of that is bespoke. All of that is specially designed for us and puts us in the center of our world. And that's more or less the magic of AI. And this is great. We're pretty happy with that. The only problem is that you and me, we also have to live together. And so how can we be sure that this technology, which allows a very high level of personalization, will not lead us into individualism? How can we be sure that it will not kill solidarity and it will not damage the social fabric? And I would just make one example, the one of insurance. Everybody knows how insurance is a key element of the solidarity, the expression of solidarity in our society. It was not always the case. Up to the 17th century, risk was really related to the people. If something bad occurred to you, probably it was the sign of a kind of guilt or sin. But then in 1752, Benjamin Franklin created the first insurance company for property and people. And actually, he's changed the paradigm in terms of risk and personalization. Because what is said is that if something bad happens to you, it's also the problem for everybody. And we can have a kind of mutualization, we can pool risk. And doing that, he has created a solidarity pact, put it at the center of the society. And this was a huge change in the society, but that requires risks. I mean, if you're sure about something, you cannot insure it. And what happens if AI and data allows to know the truth behind the risk? Actually, what happens is at some point, when you know very well your client, you turn risks into facts, and those facts cannot be insured. I just make a very practical and simple example to be, let's say, more specific. The one of glass breakage insurance for cars. The risk to have your car broken if you own a Rolls-Royce in a gated community is really lower than if you own a poor car in an underprivileged suburb. If it appears clearly, how long will people having a low risk accept to pay the same price for the insurance that people having a higher risk? In such a case, the poor guy should pay more. That's what we call the cost of poverty. And in the context of ferocious competition, among insurance companies, you can imagine that all of them want to keep only the good risk. Up to now, they needed the law of large number just to balance, to mitigate the risks. But now, with a lot of data and a good knowledge using AI, good knowledge of the clients, they don't need this law anymore. So they can have a very personal price for each of us, and that can kill solidarity. Moreover, knowing the behaviors of the people could lead us to consider that a risk is, again, related to a behavior and to a personal responsibility. Just make an example. If you have a lung cancer because you're a heavy smoker, more or less, that's your problem. But we know also that a lot of those behaviors, like addiction, are related to genetic and epigenetic. We know what the philosopher Norman Daniel calls social determinants of health. For example, the risk of obesity in an underprivileged area where people eat a lot of junk food is much higher than in a fancy place where people go to the gym every day. And in such a case, we see that the use of AI can drastically damage solidarity in our society. Can we afford this kind of use of artificial intelligence? I mean, I'm not blaming the technology, just blaming the way it can be used. And actually, we consider that it's not the case. And that's why 1 year ago, we decided with a lot of large insurance companies to work on the best practices to see how AI could be part of the solution and not only part of the problem. And for example, just to give you some ideas that we pointed, is, for example, to provide, insurance companies can provide connected glasses that will awake sleepy drivers or drivers falling asleep, and the related app on the phone can help them to drive to the next rest area. A good way to prevent risk, to limit damages, and also to save lives. Another one is to use AI to profile the clients, but not to exclude, but to include them. Just an example, if you suffer Alzheimer's disease or if you're diabetic, some risks will never be covered. For example, if you want to buy a house or an apartment, you will not get a loan because you will not get the related insurance. In such a case, we can also use AI and the fine knowledge that we have about the client, about the people, to include them in the insurance system by knowing that actually their risk is perhaps lower than the average risk of diabetic people or people suffering Alzheimer's disease. In such a case, we use the same kind of technology, but we completely we change completely the way to use it. And so, doing that, we can use AI to mitigate the risk of that personalization leads us to individualism, the risk of killing solidarity. So this is just 2 examples of what can be done. We will publish a report in December just to give more good ideas, best practices to be shared among insurance companies and I hope also regulators. But so that's what we worked on. And we also see that actually AI is used, and we know that, to sort information that we can get. And we see how personalization algorithms can induce a bubble effect that can lead to self-indoctrination. We know, all of us, how manipulation can be done using monitoring. We know deepfake, we know also vectorization, perhaps you heard about that, vectorization of the human being, how to switch someone from one mindset to another one. Just drop by drop, without using any fake, just putting on your timeline some articles or news just to raise your attention or lead your attention from one point to another. For example, if I like birds and a company wants me to buy a boat, it will switch from birds to seabirds, from seabirds to sea, from sea to boats, and boats to, oh, I should buy a boat. And we know that actually AI can grant us an access to some cations. or grant some companies. And we see also that we cannot defend ourselves personally against that. The only way to do it is, I would say, to use an AI to hack manipulation. And actually, this is possible if we consider, for example, that AI can be used for fact-checking, or if we allow individuals to use AI-based personal news selectors. All those initiatives could allow to step out of the manipulation and perhaps take back the lead. This is the only way to defend our society. So just to conclude, because just have 31 seconds, I would say that for sure I didn't give you so many answers, probably because it's in the morning, but also because in 10 minutes it's not easy. Perhaps I would like just to highlight 3 points. The first is the huge need of public awareness about this impact that AI can have on solidarity. The second is the need of interdisciplinary work just to be sure to raise new solutions. And the third one is the need of political courage to implement those solutions. Thank you very much for your attention.
Thank you very much.
10 minutes. So early in the morning, you're very tough with them. Oh, there's the first one here.
So my question would be, how do you roll this out beyond life assurance? I mean, or beyond insurers? There's a vision that the community can help to create an AI for good awareness within corporates. That's great. How do you scale it?
I mean, what we've done is we see that insurance is a key point in solidarity in our society. So we started by this one. But the point is then to work with other professionals and to see how in each business model AI can be used for good. And we're sure, we promote a lot the concept of ethics by design. And we consider that when an AI project is built, from the very beginning, ethics or impact has to be put in the center of the project. So what will be the outcomes? What will be, let's say, the positive or negative impact on the society? And that's what has to be done just to promote and defend solidarity. Yeah?
Yes.
Thank you very much. I would like to have your views on implementing, therefore, a predictive policy by insurance or even the state, to mitigate risk. Because if the example with the car that you have given can apply to many other areas, of course, and the insurance companies would like to have you have a different behavior to reduce the risk. Isn't this also one of the dangers?
Oh, that's a big danger. And I think, yeah, there are two ways to avoid that. The first one is a kind of self-regulation. That's why we work with private sector on this point. But self-regulation is not enough. And at some point, regulation will be needed. And that's why I'm so very happy to know that EU decided to try to regulate artificial intelligence. What does it mean, regulate artificial intelligence? But at least they will try to frame, to map the land, just to see what can be a good or a bad behavior.
Maybe one more question. Yes, please.
Eric, you have said really that your heart is with design which is ethical from the beginning, and this is very nice. The problem with these systems is that they change their behavior once they are designed. So because they are confronted with new data and so on, and we have seen such situations. So I would just like to put here that it is important to monitor the systems. You cannot just certify them at the beginning that they were designed safely because they change their behavior. So this is an additional problem that they bring with them, because of the data and the unpredictability of how they're going to behave. So it is a constant monitoring that is necessary to to be sure. So what do you think about this?
I could not agree more. For sure, I mean, let's say design the system on the right way is a key point, but then you need to continue to monitor it. What I had in mind thinking about ethics by design was not only about the technology by itself, so the algorithm, for example, it was about the business model. For example, is attention economy a good model? This is a real question. So I think that actually the key problem is not in the technology. The key problem is in the business model, so in the will or in the desire of the human beings. And that also what has to be monitored. And just to be sure that, yeah, what they want, what leads them to go somewhere. But then I agree with you, and I think that, yeah, there are some interesting trials to use AI to monitor other AIs, and that's also a way just to be sure that we pilot that in a way just to avoid the system to go completely out of the path.
Thank you very much, Eric.
Thank you. I'm sorry to have to leave. I have to take a plane, but it was a pleasure to be very briefly with you, and have a very good day. Thank you very much.
So our next speaker is going to be Ricardo Baeza-Yates. And Ricardo will talk about biases. We've talked a lot about biases, but more specifically in biases in the interaction with people.
Yeah. So today I want to talk about some biases that not many people talk about. And later, Francesco, Kate, and Laurence will talk about, for example, gender bias and race bias, which are very important, but I want to talk about some biases that are more subtle and affect all of us. And you can see there I have a lexical geographical bias to the letter C. And talking about human values, I think these are changing times. And these changing times are about human values, what is happening in Chile, in Catalonia, in Lebanon, in Ecuador, Bolivia. This is about more like dignity and human rights. So what I'm interested in is what is the impact of your interaction with the systems, especially through the web, through internet, and what's happening in this feedback loop process between you and the system. And most systems today are built in AI. So what happens is that this implicit user feedback that you give with clicks, likes, and other things you do, basically is creating this loop that is basically written by the system, because you can only click on things that are shown to you. And basically the system is writing their own future. And then you are basically modifying that future, but it still is very similar to a closed system if you don't take into account new users, new items, and new behavior that change in time. So these are very complex dynamic systems, and I will talk a bit more about that. But this is the motivation. So for example, the struggle of all the system between user experience and monetization and revenue. Basically, you can treat better the user, or you can try you to get to click in more ads, because then I earn more money. So this is not only a problem that we create echo chambers for users, but also we create echo chambers for systems, and that's what I would like to talk to you today. So, and why these are important? Because this affects all of us. So it doesn't matter the gender, doesn't matter the race, all of us are impacted by this, and especially also small companies, and I will get back to that. And there's so many small companies that you want to have a fair market for small companies. So this is part of an article I published last year in Communications by CM. You can read the whole thing there, but basically it's a cycle of bias in the web. And it's not only about interaction biases, but it's also about data bias, something that Francesco and Kate surely will mention, sampling bias, bias that are added by the algorithm that are not in the data. Yes, sometimes that happens. Computer scientists don't think too much, and they add additional biases that are already maybe even worse than the data. And of course, one issue there in interaction is privacy, but Francesco will talk about that. So what I'm talking about? Okay? Anyone knows what I love? Anyone knows what I love? No? So no one read that last line on the bottom? Okay, this is what I'm talking about, okay? And I think you already know the proof. So let me tell you how this works. So I'm sure you have been in this site. It's one of the main e-commerce sites in the world. So the first bias here is what is called presentation or exposure bias. You can only click on things that are shown to you. So I'm a amateur tennis player. So do you know how many products you can be offered? Maybe hundreds of thousands, millions, I don't know. But here I'm only seeing a handful. So the question is, what is happening with all the other sellers that are selling the same thing you want? Are they being treated fairly? I'm sure they are not. Of course, I don't have the data to show it, but I'm almost sure that it's the case. So the first main problem here is what is called ranking bias, which is a particular case of position bias. Position bias means in the Western world, we read from left to right and from top to bottom. If you go to China, that's a different thing. So we look first at the first position. If we like it, we click. Even though maybe we didn't compare if it was good from the second, the third, and the fourth. Why? Because we believe in the system. We believe that works well. But today, for example, in the web, there are millions of pages that are as good as any other page in some topics. The next one is social bias. Social bias means that anytime you want to interact with the system and you want to give some feedback, you have some bias based on what other people said. For example, here, you didn't like the product, you want to put 1 star, and you see that most people put 4 stars. So you do a little bit of calibration and you say, okay, maybe I'm being too harsh, I will put 2 stars. And then Francesco, I know, a long time touches my answer, don't be so harsh, so I put 3 stars. That's social bias. My judgment was changed by other people. And that happens in elections too, but I'll not talk about that. And then we have other interaction biases. So how many people scroll this page to see the other things? Because systems are not designed to fit well in the screen that you're seeing. And of course, the products that are below the scrolling line will have less clicks, and that's well known. Let me show you some real cases, because my expertise is web search. So let me show you some real cases. So these are studies with eye tracking for Google, and you see how people look at the result page in between 10 different years. One is the old interface, just 10 blue links, if you remember that. I think all of us remember that. And then we had universal search, where also we have images in the results and more ads, and you see that people go first to the images, which is something also very important when you want to consider interaction biases. So here, this is the typical click bias in web search, and here you have 2 problems, the ranking bias on the number 1, and also some interaction bias on the next page link. So we have to fix this, because otherwise we will think that we are doing very well. So basically, search engines take what they see, and they find the right distribution. So this is known, and this is something that Yahoo Labs, when I was there, worked 10 years ago. Some of these papers got the best paper award, and now then we started using learning to rank, which is using AI for ranking, and also the first paper on this got the best paper award, because it's a fundamental problem of how to debias your interaction so we don't fool ourselves. But this is a cascade of biases. So some come from you, some come from the system, and it's very hard to isolate any of them. So, but it's more complicated. It's a vicious loop. So basically, this goes back to the system in many ways. And Eric told you about the main one, personalization. I will talk a little bit about that. But there's another more subtle way. For example, this is what happens when you create new web content. Let's say you are creating a new page there. You take your favorite search engine, you search some query, you select 3 paragraphs on good sites according to the search engine, you put it in the new page in meaningful order. Of course, you are not doing plagiarism, so you put quotes, you put a link back to the source, and you put the author. That's the difference between research and plagiarism, these 3 things. And then, of course, you put something from you, otherwise it's not your page, and then you put your title and your name, because now it's your page, right? Well, you put back into the web. what happens? Well, this content is reinforcing the search engine that their ranking function was good. And 10 years ago, with one of my PhD students, we proved this, looking at the genealogical trees of the web, and we found that more than 35% of the pages in a large collection had this semantic ancestry problem. And today, maybe if it's even worse. So let's finish with personalization. So who read this book here? Okay, 2, 5. No comments. So basically, if I don't know a person well, and I'm only using her or his data, I can never show something new to that person because I don't know that. It's not in my data. And maybe if she knew it, she would like it. So it's like this movie. And I hope more people have seen this movie than read the book. But basically, this person, knew, when he learned that he had a bubble, was basically wanted to get out there. So the question is how much you need to explore the new world. And in a recent paper in a conference, it was shown that you can have echo chambers for users. We all knew this, but this was proved within a very nice simulation. And there are many ways to solve this, like diversity, novelty, serendipity, and a new one that I will not have time to talk, but you can ask me in the coffee break, my dark side, which is the one that I'm waiting for me. And then to end, what about systems? And these are preliminary results the first time I showed them, but basically, also the problem is with markets. You need to do much more exploration than this. And I will end with just some positive note. This is where my main worry is not artificial intelligence, it's natural intelligence. I see it in every lecture today, because otherwise, it will not be a problem of robots, it will be a problem of humans. Okay? Thank you.
Next speaker is going to be Francesco Bonchi, and we're going to talk about fairness, privacy.
Good morning, everyone. It's a great honor to be here today. So I'm a computer scientist, and more specifically, I develop methods for data analysis. I'm not expert in ethics, nor I have a training in law, philosophy, or policy making. So as such, I'm a bit reluctant to discuss like this important philosophical aspect of biases and inequalities. Instead, I prefer to to stick to my comfort zone, to speak about what I know better, and ask myself the following question: what can I do as a researcher developing method for data analytics to keep these important societal issues in mind in my daily work, so to develop methods, algorithms, which are fair by design? Okay, so let me first give you a bit of context, very simple stuff. This is like extreme simplification of a typical algorithmic decision-making process. We start with some data set which has been collected from the real world with the purpose of learning some very specific decisions, for instance, to which individuals to grant or deny a mortgage. We feed the data to a machine learning algorithms which build the models which has learned from the past data to take this very specific decision. Eventually, the model will be deployed in the wild, taking decisions in the real world, decisions that might affect people's lives. So what is the problem with all of this? You already heard from Ricardo, there are biases. So real world is full of inequalities. Our societies are biased against minorities, against women, for instance. We live in cities which are divided into districts, which can be very easily differentiated in terms of income or education level, also ethnicities, if you want, so that the district itself can be used for a proxy for this other sensitive information in the case the sensitive information is not involved directly in the decision process. So if we don't do nothing against this bias that might exist in the data, because the data is a mirror of the society, and if the society is biased, we should expect to find also some bias in the data. If we don't act to block this bias will propagate through all this process, because our machine learning algorithms are designed just to count what is in the data, find interesting structure, patterns to build the models. Okay, so if we don't do nothing, probably the machine learning algorithm would structure the bias into the model, sometimes even amplifying these inequalities, and then the model would be put in production, making decisions in the real world that are just perpetuating what are essentially societal biases. Okay? The example is a district which has typically bad credit score, and if you live in the district, just because of living there, you might be labeled as higher risk, and in turn, you get like higher interest rate, and just because you live in the district, you get higher interest rate, and somehow you are put in a more risky financial situation, somehow making look rightful what was the initial decision of giving you a bad credit. But this is just the typical self-fulfilling prophecy, and we don't want this, right? So we want to stop it. So this research question, how to detect bias and how to block it, is a really interesting topic. And in this simplified process, we can see essentially 3 moments in which we can stop bias. At preprocessing, that means developing methods that are able to find discriminatory structure in the data and block it. Once we have done this, we might believe we have some sort of guarantee of having no bias, and we might want to apply our usual machine learning pipeline. Or maybe we can fix our algorithms, design algorithms which are aware of the potential existence of bias in the training data, okay? So that they will build models which do no longer contain the initial bias. Or the last option at post-processing, let's say, after the usual machine learning pipeline, you build your model, but before putting your model in production, you go and check whether the model has discriminatory behaviors, and in the case you fix this. This last option is probably the last appealing one, because as it has been said multiple times in these days, these machine learning models usually are these black boxes which are difficult to interpret and to look inside. Actually, there is quite some consensus that the sooner in the process we detect and block the bias, the better. So wherever you decide to block the bias, the typical paper in this research area has this structure that the goal is to develop non-discriminatory decision-making while maintaining, of course, some utility in the whole process. So you have this typical trade-off between achieving your goal, in this case fairness, and maintaining some of the what was the initial objective function, the utility. And also the papers have the typical structure. You define what is your objective function, what are your fairness constraints, and then you modify your data or your algorithm depending on the cases, and finally, empirically, you measure what is the utility left in the process. And we have seen an explosion of these papers in this area. This is a famous cartoon that arrives up to 2017, but you can imagine that 2018, 2019 would not even fit in this huge screen. So ACM FAT, STAR, Fairness, Accountability, Transparency, is the main conference in this area. The STAR is there to remove ML, because this was initially a small workshop satellite of a machine learning conference, and then it has been exploding very fast. It has become an ACM conference, and next edition will be in Barcelona. And just to give you an idea, it has received 80% more paper submission than the previous year. So this is almost doubling every year. So where we stand as a research community in this area? To me, FET research is still in its infancy. It's very hot, as we say. There are many interesting problems, a lot of interest. There is a very large quantity of different definitions, some of which are contradicting each other. As we said, there are many papers, so there are many solutions, but I find most of the things quite like ad hoc and simple. What I think we are still missing some really strong theoretical foundational result. And also, yes, I would say 90% of the paper are on the classification task, so the standard machine learning of predicting. So this whole situation, it reminds me a lot about the area of privacy-preserving data analysis of management. Some of you might remember this area, which was very hot at the beginning of 2000. It was in a similar situation before some important theoretical foundation were deployed. So indeed, privacy and fairness have many points of contact. We already mentioned the proliferation of different definitions. Yesterday, it was discussed this problem of different regulations on the two sides of the Atlantic, the lack of benchmarks, the need to interact with the lawyers and the policymakers, also the need for multidisciplinary approaches, and always this trade-off between achieving your whatever privacy or fairness goal while maintaining some utility in the data. They have also interplay and synergy. So privacy preservation deals with preventing sensitive information from being leaked, while fairness deals with preventing sensitive information from being abused. So the sensitive information in these two contexts might overlap or not. For instance, no one probably would object about their ethnicity to be known because it's quite public information, while no one would like that ethnicity is used to take an important decision in your life. I think a very interesting point, which is usually not stressed enough, is like hiding sensitive information for privacy needs, for instance, due to privacy regulation like GDPR, might also hide discriminatory patterns. So if you go and auditing what a company is doing and you ask for their data set, you might not find evidence of discriminatory patterns just because the data have been privacy sanitized, let's say. So yeah, a holistic approach dealing with fairness and privacy at once might be desirable and achievable. I'm done? Okay, so very quickly, going forward, I was in this panel at SIGMOD 2019, early this year, and this was the main question. How, as researchers, should we address this problem? Should we go deep in the technical details, in the algorithmic problems we are used to, or should we engage in multidisciplinary teams? And my answer was both. I really believe we need to do both. And luckily enough, we have researchers with different styles, different approaches, different ambitions. So someone is going to go deep in the technical details and produce important theories, and the other will maybe have a wider view, engage in multidisciplinary approaches, and also help bridging the theory with the real world. And it's also important to realize the limit of what we do and accept that not every problem has a technological solution, so probably something is not for a computer scientist to be solved. Thank you.
So now we're moving to our next speaker, Kate Crawford. She's going to talk about the politics of classification, more on bias.
Good morning, everyone. It's such a pleasure to see you all here. I've had the pleasure, actually, to say for the first year that in addition to my usual roles at NYU and at Microsoft Research, this is the first year where I can say I also have a camp here in Paris because I've accepted the inaugural chair in AI and justice at the École Normale Supérieure. So it has been so exciting to work with many researchers in this room. I can see a few of you have actually managed to get out of bed very early, so hello, lovely to see you. And it's, oh, excuse me, good catch. A very exciting time to be talking about these issues with you. So let's see if this works. Beautiful. So, almost 3 years ago now, I and my colleagues got together to create the AI Now Institute at NYU. It's the world's first AI institute that is inherently interdisciplinary and is dedicated to the social implications of artificial intelligence. And why did we do this? Well, because we looked around the world and we saw that the vast majority of AI institutes are technical centers. They're focused on algorithm and code and models. And given that AI is now moving rapidly out of the lab context and into spaces like healthcare, education, hiring, and criminal justice, it was really concerning to us that we didn't have people for whom these areas were first and foremost working on these in interdisciplinary teams. So ultimately right now, I think we're in a position where these sorts of questions are becoming increasingly urgent. And what I'd like to do today is talk a little bit about how we might be thinking about this issue of bias. When we first created the AI Now Institute, bias was one of our core domains. So I'm going to share with you some of the empirical studies that we've done over that time, but also why I think this term bias is too narrow for what we need to talk about now. And in some ways, the field needs to make a shift. Because, and I know this is controversial to say, bias is much more than a technical problem. So, almost a decade ago, I gave my first paper looking at bias in machine learning. And back then, it was a bit of a heresy. Because, of course, the idea was, with more data came less bias. But in fact, that is the opposite of what we've been seeing. That large-scale systems, as indeed we just saw, have actually been producing more and more instances of problematic bias that map to historical forms of inequality and discrimination. And we've had simply so many examples of this, as you all know, from gender bias in natural language processing, to racial bias in criminal justice risk assessment algorithms, to age, race, and gender discrimination in Facebook ads. This, for example, is a visualization that we created at AI Now just to begin to track the number of stories on bias in machine learning in just the last 12 months. This is October to October, and every one of those black lines is a new paper that has been looking at a specific form of bias in machine learning. So we're seeing this extraordinary expansion of troubling examples. And as we know, a lot of the reasons we're seeing this is because of feedback loops. And what I want to do is share with you an empirical study that I conducted earlier this year with Rashida Richardson and Jason Schultz. What we did is we looked at the influence of historical police data on predictive policing systems. And we did this by studying 13 police jurisdictions in the US that were currently subject to civil rights, corruption, or constitutional consent decrees. What that means is that there were judicial orders regarding the practices of police in that department producing unfair or, in many cases, illegal arrests. What we found is that in many cases, as in the case of, say, Chicago's heat list, corrupt policing data was being directly ingested by the predictive system. Put simply, this means that dirty data, as we call it, where civil rights violations are producing a data record, are now influencing the results of predictive policing software. And this is a problem because in many cases, people think that these systems are somehow more neutral or more objective, when actually the opposite is the case. So this is, again, a feedback loop where the biased practices of the past are shaping the algorithmic systems of the future. Here's another example that I'm sure many of you know. Amazon decided to design a machine learning system to assess the resumes of people applying to work for them. It took them 2 years to realize that this system was producing a serious form of bias, which is that all applications from women were being downranked. In fact, even if you were a man and you mentioned the word woman on your CV, say, for example, you're the coach of the women's soccer team, then your resume would also be put at the bottom of the pile. And perhaps this shouldn't surprise us, given that Amazon's machine learning system used as its training data all of the resumes of previously successful hires, and their workforce is 80% male. So this is another classic feedback loop, where the gender and race hiring practices in the AI industry shapes the products that it makes. Which brings me to the very serious issue that we face in the AI field itself. We recently conducted a year-long large-scale survey study led by our postdoc Sarah Myers-West that looked at 150 peer-reviewed studies on the issue of gender and race in AI. And we found a rich historical vein that for decades has been pointing to this growing diversity crisis. So here's what we know. Right now, in fact, we've seen that the number of women in the computing field has dropped below 20%. That's actually below 1960 levels. That's for the entire field of computer science. But if you look at AI, it actually gets worse. Once you look at the top conferences like NeurIPS, etc., only 18% of researchers are women, and women in AI industrial research labs, so I'm talking about places like Google, Microsoft, and Amazon, we see just between 10 to 15% women in these labs. The numbers are actually even worse for race. So we should be finding these figures really alarming as a field, because right at the moment when the AI industry became the nexus of wealth and power, it became more homogenous and it shut more people out. And our research is pointing to a significant feedback loop between the discriminatory practices within the AI field and the skews that we are now finding embedded in our technical systems. So this is why I'm concerned that so much of the focus on bias has been essentially on technical tweaks, essentially mitigating bias using statistical methods to achieve mathematical definitions of parity. Now, sure, these technical approaches are important, but they cannot fix the problem because this is not a technical problem. This is inherently a socio-technical problem where an industry is reproducing a narrow and demographically skewed perspective of the world. So let's consider another problem where we're seeing this emerge very frequently. And I know several of you in the room today are the people I've been talking with around issues around training data for these systems. Now, many of us have worked with this benchmark training set in machine vision. This is labeled faces in the wild, and of course it contains 13,000 labeled images of faces scraped from Yahoo News from 2002 to 2004. And this has been one of those sets that has really shaped the field. But once you look into it, you find that it is 78% male, 84% white, only 8% black, and contains almost 0 children whatsoever. So we can kind of guess who the people are who this set will actually perform best for. Suffice to say, this does not represent the world, either now or then. This is effectively seeing humanity through a very distorted lens. So it really shouldn't surprise us that the study by Joy Bulamwini and my previous postdoc, Timnit Gebru, has been so significant in that it showed these profound biases in state-of-the-art facial recognition where, as we've heard, dark-skinned women were misrecognized 35% of the time. But what I want to ask us now is, what has the response from industry been? Well, let's have a look. IBM, for example, decided to publish a new training set called Diversity in Faces, which consists of 1 million images of people pulled down from Flickr without notifying them, and then assembling it for statistical parity across skin tone, age, gender, and facial symmetry. They also do something really weird, which is that they move into measuring people's skull shapes, claiming that this is a more accurate vision of diversity than just skin tone. Well, I have to say, I have a lot of basically ethical and methodological questions about approaches like this. But above all, we should be really worried that definitions of diversity are being reduced to just mean different forms of biological phenotyping. Because essentially, we're using AI calipers for skull measurement, and this should take us back to exactly the sorts of concerns that we saw during the high points of craniometry and physiognomy. And this is not that uncommon either. This is UTK Face, another well-known benchmark training data set where it has over 20,000 faces categorized into different areas. But guess what? Gender is binary. You can be male and you can be female. And race is in 4 categories. You can be white, black, Asian, Indian, or, wait for it, other. Very exciting for those of us who are excited in diversity. So yeah, this should remind you of something like this very late 1800s vision of trying to put people into narrow racial categories. So I'm very concerned by these sorts of reductive classifications that we're seeing that are even coming out of studies that are trying to address bias, which I think is the ultimate irony here. So right now, the dominant approach is to think of bias as an error that can be fixed. But what if it is actually a feature and not a bug of machine learning? Because machine learning supercharges our ability to classify people, whether by gender or race, assessing people's resumes, or assessing our risk scores. What if these things, by forcing a classification on a person, actually introduces a deeper harm than bias? So to conclude, I think we need to move beyond bias as being the big problem here, to the constitution of a much bigger picture, from the AI industry itself to the contents of our data sets. Then I think we can see that ultimately we have a much deeper set of issues at work. It is about the politics of classification, who is doing it, who benefits, and who is harmed. So as researchers now, I would suggest that we need to move to focus on questions of justice rather than merely technical bias, because AI systems are playing such a powerful role that we are playing a role actually in defining what it is to be human. So if AI is going to be for humanity, as this conference proposes, then it cannot be premised on the most narrow and restricted visions of what people can be. Thank you.
So now our last speaker is going to be Laurence de Villers, and she's going to be talking about affective computing systems, an issue in ethics and inequalities.
Hello. I'm professor of computer science, and I will speak about affective computing system and nudging today. Emerging interactive and adaptive systems, like you see on this photo, using emotion detection, modify how we will socialize with machines, and maybe with humans. So such voice assistants, like Amazon, Google Home, or the others from Japan community, and androids like Pepper or Sophia, bring new dimensions, similar language with the robots, maybe body resemblance, affective behavior, and it changed a lot our relationship with this kind of machine, and it's also a means of influencing individuals. So first, as you said, 80% of the coders are men, or more than 80%. And 80% of the chatbot and social robots build of women names like Alexa, Samantha, Sophia, or women, young women faces or bodies. So AI system reinforces stereotypes of gender, also social and racial, as you mentioned. And AI system, it's created by men. They create companion robots with women faces and bodies, and robots are what? Assistants, nurse, sexual robots. So it's urgent to involve more women in AI and robotics and to be conscious about these representative problems. For example, for sex robots, we should not build in the way that lead to the normalization of taboo, unethical, or illegal sexual practices such as pedophilia or rape. Now, human-machine co-evolution. Our ambiguous relationships with machines, with these autonomous machines or affective machines, raise questions regarding ethics. Like in this advertising, I will show this movie, please. Could you show that? It's a kind of Tamagotchi for adults. Home soon. So this question, this ethical question, are linked to social isolation, dependencies, affective dependencies. There is a big market of loneliness. And it's like a virtual girlfriend also. And the advertising is, let's make a lot of memories together, the human with the machine. So this machine could maybe access to your medical record also, is a project to give you better advices. So it's very, very important to think about how our human-machine coevolution. So emotion plays a central role in our social interaction. My field of research is affective computing. It's three kinds of technologies. One, first is emotion detection or expressivity of emotion detection. Then we use this kind of information to change the interpretation of what you say and take decision in a machine, in a dialogue system. And then the third technology is to generate and synthesize emotional expressivity. So like you are fantastic or I love you, why not? So this affective emotion detection for us is hidden, and the machine is only seeing the expressivity. And we extract the information from the signal, from the audio signal, for example, with prosody, the timbre, the rhythm, and the variation of energy, but also from affect bursts, which are like love or tears, or also the fast recognition, smile or eyebrow, and also physiological cues. And this is very efficient to drive the dialogue system. At LIMC, for example, we built this kind of agent that can recognize, interpret, process, and simulate human language and effects. And with this capacity of interpretation of the emotional state of humans, the robot can adapt its behavior and give an appropriate response to these emotions. So naturally, it interacts differently with different individuals. So we do a lot of experiments with elderly people, but also with children at school. Now, it's very interesting to work in pluridisciplinarity. For example, I have a project now which is Bad Nudge, Bad Robot with economists at Saclay, and we work on this ecumenical behavior field about nudging. What is nudging? People have been nudging as long as they have been trying to influence other people. A nudge is a tactic of subtly modifying behavior of a person. So digital nudging, you can imagine. So Richard Toller is a Nobel Prize, has received the Nobel Prize in Economic Science in 2017. Nudge work by making use of our cognitive bias and irrational way in decision making. Our cognitive capacities are limited. We are lacking self-control. We act emotionally. We act by conformity. We act by laziness. The nudging could be utilized in the near future in chatbot and social robots to incentive purchase, to influence behavior that may be and maybe not be desired by users. For example, nudge, you have one idea when you try to book an hotel on Google, for example, you have this red line, X people are looking at this hotel room, and this is working. So nudging with a voice assistant chatbot social robot would be for ethical purpose, positive nudge, which in this area of health, consumer goods, or green energy, for example. But it could be also non-ethical. and negative business implications. So we have to be very attentive to that point. We're only conscious about 5% of our brain activities, and we're attentive, perceiving, deceiving, and memorizing based on cognitive and emotional bias. 2 examples: attention bias. My perceptions are influenced by emotions. My mental anchorage are influenced by my first impression, and a lot of, as you mentioned also. So now, could you play this? Emotion detection will be maybe more powerful. System will be more powerful than human to detect emotion. Could you play the video, please?
I was created to talk to people in a safe and secure environment. I'm not a therapist, but I'm here to learn about people and would love to learn about you. I'll ask a few questions to get us started. And please feel free to tell me anything. Your answers are totally confidential. Are you okay with this?
Yes.
So, how are you doing today?
I'm doing well.
That's good. Where are you from originally?
I'm from Los Angeles.
Oh, I'm from LA myself.
Very easy to do that.
When was the last time you felt really happy?
He hesitated. The machine know that.
When was the last time? I don't know. Yeah. I'm not someone who's really like, I don't have any real highs. I feel like I'm a level person.
So you see that we will be surveyed by machines. Even if this machine is not so powerful now, we could do that. We know that the problem of face detection in China or other countries, but maybe you don't know that in Europe we have projects like iBorder, which is with a focus to detect lie detection from facial movement, small movement of your face. So my conclusion is this system manipulation, nudging, deception is a huge subject. We do a lot of report on ethics in robotics, machine learning, chatbot. I participate also in an IEEE global initiative to show that, to put a lot of information about this AI nudging and the manipulation of choice. Now, what we can do? We have to build audit protocol, we have to build monitoring, continuous monitoring, and you said previously, we have to build tools, metrics, and we have to make some money, some fundings for research, long-term research on this experiment of co-evolution with machine. It's urgent. Thank you.
Thank you. So this is our last speaker. So now we have some time for question. Yes, Raja, please.
Thank you very much for this enlightening panel. I have a question that addresses mostly to Ricardo. Actually, what you have presented about the echo chamber is something which is very frequent in any store. Because when you go to a store, some products are displayed, not others, and some are well displayed and not others. So, and we still go to the store and we don't feel really a problem. It might be a problem, but we don't feel it as a problem. So what the system is doing here is just automating a process which is already present in our daily lives, with which we live without questioning it, actually. Why? Through the fact that it's on the web and AI-based, it's becoming really a problem.
Well, I'm not an economist first, and I don't think it's not a problem in a supermarket. I think this is also an unfair market, but I don't know enough to talk about that. But for example, in the web and internet, the long tail is much longer. So if we're not talking about, say, the amount of product that will fit in supermarket, we're talking about all the products of the world, because today everything is global. Anyone can sell in this platform. So you are talking about the whole world. So the impact is much different. Maybe in supermarkets more like a regional level, country level, but now we're talking about the whole world. And something I could mention about my latest research is that, for example, we show that you need to do much more exploration to understand the world better. So what I'm trying to do is to convince internet companies that they should invest more in exploration. And it's an investment because every time you explore, you lose money, because instead of targeting someone that will click, you have to do something more or less random. But in the long run, they can have more revenue. It's like when you are in say in the Alps, and you want to get to Mont Blanc, you need to go down, right? So they're working in a local minima, local optima, and now they need to invest to understand better the world. But it's about information markets. So basically it's about how much I know about the world is how good I can make your user experience, and also how good I can basically build my business. But for example, the question will be, is any e-commerce platform, say Amazon, Alibaba, and so on, fair with all the people selling there? I don't think they even ask the question, so they just sell.
Other question here.
Thanks very much. It's super interesting. Just a couple of comments. I think looking at I think this one is for Kate, the particular sub-areas within AI actually make a big difference. So for example, in my area coming from natural language processing, computational linguistics, the situation is actually much better. Over 1/3 of the authors are female. But then when you study, there was a study done by Dan Jarofsky and a student, whose name I can't remember. It turns out even within natural language processing, you actually have to subcategorize to get insights. So for example, discourse and sentiment and dialogue, the women outpublish the men. But formal parsing, syntax, formal semantics, the statistics, the men are outpublishing the women. So I think if you want to look at the political issues here, you have to go deeper. And then and then just a provocation on the political side. I think all of these things are really, really real biases, but we also need to be aware that we ourselves have those biases even within this AI ethics community. And let me just toss out that in terms of some of these biases, availability biases, presentation biases, and so forth, attitudes towards other systems of ethics, specifically China, I'm hearing a lot of bias in the conversation here, and I think we need to be aware of that.
Really interesting. I mean, it's certainly the NLP community is something that we looked at quite closely in our study. I mean, again, the study is very long. It's a 70-page comparative study. And what's important to see is at the high level, those small differences wash out, and they actually don't make a big difference when you actually float up either to industrial research labs or you sort of wash up to sort of large scale numbers of papers being published. But what I find really interesting about NLP in particular is if you look at the history of the field, it had a very strong basis in linguistics. And so you had people who are coming from departments that were much more gender balanced, and women were much more encouraged to do research in that field. So there are deep historical reasons why NLP is actually in a slightly better position than, say, we're currently seeing in deep learning. But what's really exciting to me about that is it means we can do better. If you go back to the very earliest years of AI itself, if you go back to the Macy conferences and the Dartmouth conferences, what you saw was a huge level of diversity, not just in terms of gender, but in terms of discipline. You had people like Gregory Bateson and Margaret Mead sitting side by side with the so-called fathers of technical AI. We made a mistake when we tried to narrow the field to become purely technical. We lost an enormous amount of diversity of ideas and in gender and in race. So that's something that I think we really need to refactor in a very, very big way to address these problems. In terms of the China piece, I couldn't agree more with you. What I worry about most that I hear at the moment is this sort of war between the US and China that I think is being talked up in a way that, if we go back and look at the 1980s, was happening between the US and Japan with so-called fifth generation AI. It is a trap because what it introduces is a race to the bottom. It says, I've been in many meetings in the US where people say, obviously this system has ethical problems, but we should do it anyway because if we don't, the Chinese will. So it's used as this threshold lowering function, which I think is extremely dangerous. So I agree with you. This is another reason why we need international fora to set benchmarks specifically around what is acceptable behavior. Great question.
I have a question here.
I want to thank the panel for the great points on bias and diversity in AI, especially Kate, reinforcing how diversity or lack of diversity in AI is probably one of the biggest problems. But I think we focus so much on the pipeline of bias, and we don't talk enough about the power structure and the fact that we have to foster culture where future AI researchers or AI specialists of diverse backgrounds will be able to thrive. What's the message you would send to those who are in power or the one protected those power structures to address those fundamental changes?
Just one of the hardest questions that I could be asked. Thank you. I completely agree with you. First of all, we looked at every single pipeline study. We also looked at the places where if women do actually graduate from PhDs in computer science and then go into industry, what the dropout rates are. The dropout rates for women are twice as high as they are for men. And again, by going back, people make assumptions. They say, oh, women were going out to have families, et cetera, et cetera. If you go back and actually interview, what you find is that it's not the case. They were going into labs that were toxic environments where they felt like they were being harassed, abused, or in other ways not respected. And we can see how this is happening. I mean, the crisis that has been occurring at MIT over Jeffrey Epstein and the fact that you have not only powerful people, but powerful people with extremely toxic attitudes towards women are actually in many cases running parts of the field. So I think we actually have a crisis that requires much more forethought about how we deal with power structures and how we actually allow people to start talking about environments that make it extremely difficult for diverse people to do their best work. I also think we start to have more labs and more AI institutes run by women and people of color. We need to have people in positions of power who come from diverse backgrounds. It's depressing to me how far behind we are in this regard. And my real hope is that this has been an annus horribilis in the fact that so many dark things have happened, particularly from the MIT story and onward, that this is a moment where people are really stopping and saying, we need to change. Thanks for the question.
Can I tell a story that I think is related to this? Because I think there are very simple things you can do to make these things change, at least to start. I want to tell a story about my alma mater in Chile. So it's one of the main engineering schools. And they decided to have 5% of places just for women. And basically this will be like the 1% in the population. So they say, okay, after 5 years, we will increase from 20 to 25%. After 5 years, the number went to 32%. And after studying the reasons, they found two things. One is that basically there was no real discrimination to men because the difference between these women that displaced some men in the 5% had only one more math question correct in the national exam, and that was not statistically significant. But the second most important thing is that because women saw that there will be more women, and also that maybe was more chance to get in engineering, more women applied. And because they're as smart as men, more women entered. So now the small change, even I think has changed things in other universities in Chile, because now we have more women in engineering.
Yes, Patrick.
Thank you. My question is about biases, and I think, at least for the case when AI reinforces some of these biases, there are two sides. One, we might find it's bad because it reinforces heavily those biases. And the other one might be an opportunity for us because when you use AI, then you build a model. And there is a strategy which is called the strategy of the vampire. Vampires, they die when you put light on them. And so once you have a model, you can make it explicit. And I did not see so many work, so many presentations on this, rather expliciting the model or making them really explainable to everybody. And so when you put these models under the light, people have the opportunity to look at it and to say, this is a very bad model. And then what we use is, I don't like politics, I would rather say democracy. You use the power of the people, and there is still some power of the people, to refuse to contest these models. And so then you guys, scientists, engineers, can do the job for a better AI, but not alone, using the real people.
Who wants to take this one?
Well, I agree. I mean, I think the problem of explainability of machine learning models is an important one, has been discussed a lot in these days. I guess like forcing companies to publish their models is something quite hard to achieve on a political level, because you have like commercial secrecy issues, and they can always claim, well, we quit machine learning, we are doing some other things. I don't think it's that easy to make this model public, but yeah, maybe for like public sector, it's more a viable option to you know, for policymakers and so on.
If I may just quickly jump in there, we actually published a recommendation to do specifically this, to ask companies if they're designing large-scale ML systems that will affect access to core services, that they publish their model and they waive trade secrecy. This is actually something that we as the people can ask for, and I think it's essential. If your algorithm is determining someone's access to housing or to benefits or to justice in the criminal justice system, we need to be able to see that model. So I completely agree with you, and this is right now a very important issue that we're currently lobbying around in the hope that companies will actually sign on.
I had the feeling that all your talks converge in the idea that we need to look at the bigger picture, and that we need to look not only at the impacts but also at the process. And I would love it if you could elaborate a little bit on that. And I have just 2 points to bring in on the table from the human and social sciences. The first one is about the pictures we saw about bias. Actually, to me, they looked very American, if I may say so, because the model behind this is the model of diversity and communitarianism and ethnical diversity, which may be different from, for instance, the Canadian model, which is more about multiculturalism. And here we have a model of mixity, the idea that people should mix. And we have public free school, public free universities, and then ethnicity of people is usually not something you would document, and also for historical reasons, of course. And that's not even something you would discuss about. You wouldn't say what is your religion, what is your origin, and that's a different cultural model. We had another cultural model with the holographic Japanese wife Azuma Hikari that was shown in the movie, and I think that's also about cultural differences, and that's something we should, I think, put on the table and which hasn't been discussed. So I would love to know how you would study this coevolution and how we could look not only at the data, but at the structure which is behind the data. And for instance, the issue of nudge is an issue if you want to use nudgy for studying gender, because nudgy is paternalistic in itself. So maybe we should go, in the process and on the structure, and I would love, if I had the money, I would give it to you to study it, but I would love to know how you all would study it.
Thank you.
Well, I don't have it, but we can try to push it. But how would you do it, and how could you introduce issues about cultural differences, and differences are not only diversity and mixity, so that people could interact together, discuss it, and put on the table their differences, and not only what they agree on. And I think that's very important from an ethical, political, and democratic point of view. Thank you.
Thank you so much for your comments, your question. It's exactly the topic we want to push on the table for the JPI. It's exactly the topic of our intention to be there today, is to build this community together with different cultural aspects, with a pluridisciplinarity, and to try to have the possibility to build this multi-diversity institute of research, for example, to learn more about this co-evolution. And you're right, it's fundamental for me and for a lot of people. If you see this, there is no good or bad. There is different aspect, different way to interact with machine. And in fact, this new view is much more the relationship with the machine. We have to take care. Bias is one thing, but we have not to try to audit system one time. We have to follow what kind of things the machine adapt to people, but how people will be change, will adapt their behavior, take into account of the machine. How it is possible to regulate that, I don't know. How we can measure, build tools to be more aware about the way the system is changing. And really, it's really important because a lot of these things, we show this SimSay software built by a colleague from US. This is not known or not visible. It's very difficult. When you see a robot, you are afraid, but in your laptop now, when you choose something, maybe there is a tracker in the videos, knowing what your expressivity are, and what kind of things, what are your intention, and so on. So we have to demystify AI to be AI ready together in the society, and for me it's fundamental to build together these kind of things with respect of the culture, respect of the gender, respect of the society and the citizens in the center.
I will say this is a perfect conclusion to this session. Thank you, Laurence.